Hello everyone, welcome to my channel Manika Study Box. In my channel, I give you many tips, tricks and many of the concepts which children face issues when they go to higher standards too. Today I have come up with a topic of physics wherein I have seen that children face issues while they grow up and go to higher grades. The topic is of graphs, graphical representation of motion. Today we will deal only with distance time graphs. This is the first part of the video. The second part of the video will have the velocity time graphs. We'll look into what types of graphs are there in distance time graphs, and also we will solve example to get the concept even more clear. As we know, the states of motion can be of three kinds. It can be the object can be at rest, the object can be moving with a uniform speed which is called uniform motion, or the object can be moving with non-uniform speed. So that is called non-uniform motion. Now if the object is at rest, now how does the graph look like? First of all, we will show time on the x-axis. This is the norm. We show distance on the y-axis. Now because the object is at rest, so the position of the object is stationary. It does not change with respect to time. So for example, the object was standing at 5 meter, he is still standing at the same distance, 5 meter. So because it is not moving, so it will be a line parallel to the time axis, because the time is increasing but the distance is not increasing, it is stationary. For uniform motion, the object is covering equal distances in equal distance of time. This is how we define uniform motion. Now because the object is moving equal distances, let's say 5 meter in 5 seconds, like this we plotted here, then 10 meter in 10 seconds. Let us plot it here. Similarly, it goes on. So if we join the points, the graph comes out to be a straight line which is inclined to the time axis. Okay. Now the third is non-uniform motion. How does the non-uniform motion graph looks like? It will be because the object is covering unequal distances in equal intervals of time. This is how we define non-uniform motion. So the graph will be something like this. It will be a curved line. Why? As the time is increasing, the distance is also increasing, but with non-uniform magnitudes. It is increasing but non-uniform amounts. That is why it is called non-uniform motion, or the velocity is changing non-uniformly. Now, from the uniform motion graph, we have a formula that comes up, because we all know velocity is distance upon time. So, from the graph, because the graph does not show the distance exactly, it will show the points. So, how do I write this? It is S2 minus S1 upon T2 minus T1. So velocity is nothing called the slope. From the graph it is called slope. The word is slope. So distance upon time. Because the graph has points, so we have S2 minus S1 upon T2 minus T1. Wherein S2 is the final position, S1 is the initial position, T2 is the final time, T1 is the initial time. Now let us look into this formula more into detail from the example. This example, let us study the example first. The example shows there is a graphical representation of a body who is moving from A to B, where the speed is increasing. Then the body is from B to C, the body is at rest because the line is a parallel line straight to the x-axis. The distance is stationary of the object. From C to D, the body is again moving with a uniform speed. As we can see, it is a line inclined to the x-axis. Right? Now I have to find the velocity of the object from A to B. How do I write that? For B point, S2 minus S1. So for B point, the distance is 3. For A point, the distance covered is 0. Again, T2 minus T1. For B point, the time is 3 and the distance is 3 and the time is 0. Okay. So I get 3 upon 3, which is 1 meter per second. Now let us see for the second, which is B to C. What is the velocity? As we know, B to C, the object is stationary. So velocity must come out to be 0. Let us see it from the calculations if it matches or not. So what is the velocity? What is the distance at C point? It is 3 meters. What is the distance at B point? Again it is 3 meters. Upon what is the time at C point? It is 5 meters. And what is the time at B point? It is 3 meters. So we get 0 upon 2, which is 0 meter per second. So yes, we got the object is at rest. This is at rest. Now for the third case, velocity from C to D. What is the distance at D point? It is 7. What is the distance at C point? It is 3. Time at D point, it is 7. And time at C point, it is 5. So it is 4 upon 2, which is 2 meter per second. Okay. So one more thing. Higher is the slope, higher will be the velocity. We call it slope. Okay. More examples you can do from your book, and if you don't understand anything, you can write in the comment section. I hope you liked the video and you were able to understand the topic clearly. Thank you so much.